Hello everyone, this is Komati BJ working as an assistant professor in R.M.K College of Engineering and Technology, and the subject we're dealing with is EC 8095 satellite communication. And in this lecture we will basically see about unit 2, which deals with space segments. Okay, so before moving on to the unit introduction, we'll see what are the syllabus of your unit 2. Here you have your spacecraft technology, then thermal control and propulsion, communication, payload and supporting subsystems, telemetry, tracking and command, and transponders. So you'll see what are the different segments of satellites are present here in this unit. Okay. So moving on to the different segments present in your satellite communication systems. You have already dealt with these two types in your unit 1 itself, right? And what are the two different types of segments? You have ground segment and space segment. Ground segment is the one which is present on your earth, that is in your land area, and space segment is the one which is present in your space. Okay, and this is basically your satellite structure. What are the components present inside your satellite? You have your drag panel, you have your main OBC and power control unit, AOCS components, a GPS antenna, battery, drag panel, inter-satellite separation mechanism, LV separation mechanism. So there are different stages and levels of components present in your satellite, which put together makes it works for a particular purpose. Okay, have a look at this diagram, right? So we'll see what is space segment. Okay, so the space segment is going to obviously include the satellites, right? And not only the satellites, but it also going to include the ground facilities which are going to need to keep the satellites functional, right? And these are usually called as your tracking, telemetry and command facilities, that is TT and C facilities. And next, moving on to what is meant by a transponder. So in a communication satellite, the equipment is going to provide the connecting link between the satellite's transmit and receive antenna is referred to as a transponder. So what is a transponder? Which is going to provide a pathway between the satellites, your transmitter and receiver. That is usually referred to as a transponder. Okay. So space segment is going to consist of your satellite along with the ground components to make the communication effective between the ground station and the satellite. And what is transponder? Transponder is going to pave a path between your transmitter and receiver antennas. Okay, the next one is your power supply. Power supply is essential for your satellite to be working, but power supply is not the only thing which is going to make your satellite work. Your satellite is fully functional using your solar power. During the times when solar power cannot exist, at that time we'll use the power supply in order to operate your satellites. Okay, example, during the night time, during eclipses, at these times and all, we'll be using your power supply. So the power supply is used for operating the electronic equipments that is obtained from solar cells, and individual cells can generate only small amounts of power, and therefore arrays of cells in series parallel connections are required. Only then we'll get enough amount of power. Only if a single cell is going to be present there, then the amount of power which is going to be used should be very less. But for a satellite, we need some amount of power to make sure that it is working for a required amount of period, right? So that for that we need arrays of cells in order to give a consistent power supply, right? And the next one is the types of solar cells. What are the different types of solar cells present here? You have monocrystalline solar cells, polycrystalline solar cells, and thin films. These are the different types of solar cells that will be used in your satellite. Okay. So what are the different types? Monocrystalline, polycrystalline, and thin film. Okay. Here we have mentioned what is mono and what is poly. And to make cells for monocrystalline panels, silicon is formed into bars and then it is cut into wafers. For poly, you're going to make cells for polycrystalline panels using fragments of silicon that are melted together to form the wafers, right? And the next one is solar arrays. Solar arrays is going to convert energy to electricity on the International Space Station that are made of thousands of solar cells, and these are made from purified chunks of silicon. And these cells, it is going to directly convert your light to electricity using a process called photovoltaics, right? And then this is your Vanguard 1 satellite. So this is the first satellite that used solar panels in the year 1958. It was launched by the US. Okay, so these are the basic introduction of what are the elements that are going to be present in your satellite. Okay, for this video we'll cover up to this, and the rest we'll cover in the next part. Thank you so much.